Hello, my name is Laurent van Groningen, Enterprise Level Energy System Architect at Alliander. And today I'm taking you on a journey on how our company is becoming a distributed system operator. I will do this focusing on one core topic, the operations of the energy system. To understand this journey, we have two learning objectives. First, to understand that this change is a paradigm shift, not just functions adding to existing operations. Second, to understand the role of the DSO in the wider energy system. Let's start with the history. What we were for decades, a network operator. Our main focus was the grid, and the grid was built from assets. So asset management is central. We manage high voltage, medium voltage and low voltage assets, plus many secondary components like switchgear, protection, measurement and more. That's already a huge task, including construction, maintenance and managing the asset data. Next to asset management, we made an abstraction, grid management. Here we moved from the physical asset to what we call equipment to a more functional representation with equipment. Assets can change, but the equipment model is relatively stable. Grid management is where the assets are in danger. It protects the grid and enables safe maintenance work. This is what we did, and this is where we were really expert in. But something is changing fundamentally in our system. Until now, the customers connected to the grid at the connection point were reactive, meaning they would behave in a predictable way. Now, the world has changed. We have millions of connection points with very different load shapes than before. In the technical layer, we now see controllable units behind those connection points. EV are charging, heat pumps, batteries and more. They are not owned by the DSO, but they matter. They move the system from stochastic load to more deterministic behavior. Sometimes many devices are on at the same time or off at the same time. On the business side, Europe is enabling more demand and response products. Some suppress power during congestions and others reward consumption or generation at certain moments. And what is common in both technical and business sides is the time horizon. Some flexibility is day ahead, some intraday, some seconds ahead, and some's reactive. So, the operational world is not longer reactive only. We now have multiple time horizons coming into operations. So we saw the well-known operating models, we saw the new inputs, but we cannot operate this with one world reasoning. Becoming a DSO means our capabilities expand. Next to asset management and grid management, we now also need capacity management and market management. Capacity management depends on the technology behind the connection points and the demand response products that activate that flexibility. And we cannot do this alone. We need good agreements with market parties so that market participants can act and deliver. At this point, you might think, isn't that just adding layers? Well, to see why it's a paradigm shift, we have to look at the characteristics of those layers. They differ in data scale, in data dynamics, and time horizons. For example, grid management is mainly reactive solvable with manual tasks, while capacity and market management is more proactive. Now, the key point I want to stress is capacity management. Its data scale is huge because it combines grid management, all connection point specifics, market data, contracts, status, states of the smart metering and external measurements, and even weather data. And the dynamics are huge. If a forecast changes, if prices change, if the grid state change, everything changes. This means you need a strong data integration, high data quality, and you are connecting a very protected grid control environment to a very open market world. But you cannot ignore either. You must connect them. Now, the main goals of the DSOs are the following. The first goal is to offer customers a connection to enable energy transport according to the needs, reduce transport cost, and reduce waiting list. The second goal is to enable free energy markets. Markets can only work properly if the system stays within the technical limits. And the third goal is to guarantee system safety, and this is crucial. If we can guarantee safety, then we can connect customers and enable the free market. We must keep the power balance in our grid area as promised and avoid violations that trigger protections and create outages. And we must be able to restore the grid after fault. And what ties these together are the grid constraints, current, voltages, but also the ability for grid restoration after outages, and many more. These limits must be managed operationally together with market products. So, to recap, becoming a DSO is not just adding more functions, it's a paradigm shift. We operate closer to the limit with millions of connection points, more controllable units, more products, and more time horizons. All requiring professional data integration between different security zones and foremost the strong domain language. If we hit limits and violate them, we don't just create local problems, we can create outages, and that also impact the system balance more broadly. That's why this shift requires a high level of digitization combined with very specific domain knowledge. Thank you for watching.